So this video is about an integration technique called trigonometric integrals. And if you've ever seen integration problems that look like these guys, these are what trigonometric integrals look like. A lot of sine, cosine, squared, cubed to the sixth, a whole bunch of those. So we're going to describe the strategy to use to take these guys down. What's the concept at work here? And we'll actually do some examples to illustrate, because the concept underneath this is not too hard, but these problems here are like puzzles. Kind of gotta move them around with these identities over here. So let's get right to it. These problems, any of these trigonometric integral problems, they're just more u sub. That's all it is. And you've got to use these identities here to sort of move the sines, cosines, tangents, secants, etc., move them around to make that u sub happen. So let's take a look at this one. We have to remember how u sub works. I could either make u a sine or u my cosine. We have to look for something to make a u, and we have to make sure that the derivative of that u appears elsewhere in the equation. So let's take a look at our derivatives. Alright, so this is looking good. There's our cosine dx right there. So our u is equal to sine x. Looks like a good choice. And if we take a look at our u is equal to cosine, du is equal to negative sine. And we have a sine, but we have 5 sines. Remember, this means sine x all raised to the 5th. So we have 5 of them, but we only need 1 of them for the du. So u is equal to cosine is not a good idea. So if we go forward with our u is equal to sine of x plan, the u sub is as easy as this. Super easy integral. Answer to that will just be u to the 6 over 6 plus c, and then we would put our u back in. There we go. Done. Let's not spend any more time on this one. Let's go to another harder one that really forces you to use these identities over here. Alright, in this case, I could either make my u tangent or my u secant. And of course I have to take the derivative of these u's and see if they appear in my equation. So let's do that. Okay, so let's take a look at our u is equal to tangent approach. Well, if I make my u is equal to tangent, I have 6 tangents here. Well, that would just be easy as u to the 6th. Alright, great, but I still got to get rid of 4 of these secants, as well as the dx. Well, if I look at the derivative of my u is equal to tangent, I have secant squared. I have 2 secants. So that will help us get rid of 2 of these secants right here. Let's draw that out. So here I just split my secant x to the 4th into 2 of these secant x squareds getting multiplied by each other. That's just algebra. So these guys right here could become my du. So that's looking good. Got my u, got my du, but check this out. Look, I got 2 more secants I have to deal with. What do I do with that? Well, I can use this identity right here just to turn those secants into tangents. So instead of writing secant x squared here, I can just write tangent squared of x plus 1. Okay, so I just took that secant squared of x and turned that into tangent squared of x plus 1 using that identity here. Well, this is great because this is just tangent x squared. This can just turn into u squared right here, because u is equal to tangent of x. So now I've completely turned my integral into u's. The u substitution is complete. Now at this point, the integral is pretty easy. All I have to do is FOIL in this u to the 6 into both terms, and then I have a simple integral I can just do power rule on. So I won't show the work there because it's pretty easy from there. The point though is that the point of this whole trig integrals section is that you'll be faced with some problem. Got to realize that these sorts of problems are just more u sub. So you want to be as systematic as possible. Try a u. Make a u choice, try it out. If it works out, great. If it doesn't work out, try the other u and try to get that to work out. And you're going to have to be pretty clever with these trig identities over here to try to get that u substitution to work out. Yeah, these trig integrals, the concept is easy. It's just more u sub, but these things are like puzzles. Alright, let's try this one. So right off the bat, two u choices. Let's try u is equal to sine and u is equal to cosine. Let's go with the sine choice first. Let's try that out. Let's take the derivative of it. Alright, the derivative is cosine of x. So let's see how this works for us. Here's two sines right there. That's as easy as u squared. And I know the derivative of my u is cosine of x, so I'm looking for some cosines here. And there are some cosines, so let's try to get that working. So I have to split this cosine cubed term into a cosine squared times a cosine, because I'm looking for just one cosine here. So I have to split it like this. So this right here will be my du. Alright, so we got u, we got du, but we still have this extra cosine squared term happening. Well, we need to turn this into u somehow. We need to turn this into sines. If I remember this identity right here, I can use this to turn the cosine squared into a sine. This will just become 1 minus sine squared of x, using that Pythagorean identity up there. So the rest of my work carries down. And I know that this guy just turns into u squared. Just two sines getting multiplied by each other. So now the u sub is complete. All my x's are out. I got u's in. So this is a much easier integral. I just do the foiling and it'll turn into basically an inverse power rule. Now let's pretend for a minute that I made my u choice as cosine instead of sine. Well, let's see how well that would work out. Well, if I take the derivative of my u, I get negative sine. So I need to be able to find a negative sign in this equation somewhere. Well, there's no negative sign in our equation, but that's no problem. I can just multiply both sides of my derivative step here to get that negative to the other side. Okay, so now I just need to be able to find a sign in my equation here, and we have two of them. So here I just replaced cosine of x with u, so I have u cubed right here. Now I know I need a sine dx, so here's a sine dx. So I can replace these guys with a negative du. So now I'm here, but notice that I still have this last sine of x here. That's not good. I need all my x's out, and I need u's in. So I look at my identities over here on the left. Are there any equations that use sine? No, I see a lot of sine squared type of equations. Here's a sine of 2x type of equation, but no sine of x by itself. So I'm stuck here. I can't do anything else. And it's at this point when I would say, okay, my u choice of cosine was not the right choice to make, because this gets me nowhere. I can't succeed with the u sub. I can't get all my x's out and my u's in. So now I would try the u is equal to sine of x. Alright, so that's pretty much it for this video. I just wanted to give you the general feel of these trigonometric integrals. Remember, it's just u sub. It's just more u sub, and you gotta use your identities, your trig equations here, to sort of help you make that u sub happen. And practice is key here. These problems are like puzzles. You gotta work them around, work the pieces around, and use those identities to your advantage to make that u sub come out. So practice is key.